there is something wrong going on with the recording. It's turning on and off. Can someone turn on the recording again? Okay.
I did.
It's already on now.
Yes, I did it.
Okay, thank you. So the question says there is an encryption description system that consists of three elements: encode, transmit, and decode. An encode error occurs 0.9% of the messages. So that's the probability of an encode error. Transmission errors occur in 1% of the messages, and decode error occur in 0.1% of the messages. Assume that the errors are independent. What is the probability of a message with no error? So when you send any message, there is a chance of having an error. Any of these three errors. You can have an encode error in the message, you can have a transmit error in the message, you can have a decode error in the message. The corresponding probabilities of these errors are given. So the probability of having an encode error the probability of having an encode error is 0.009. That is 0.9%. So be careful when you convert this percentage to probability, you have to divide it by 100. And then the probability of transmission error is 0.01, and the probability of a decode error is 0.001. Now this is very important, the one I'm going to highlight. Assuming that the errors are independent, what is the probability that there is a message with no error? Saud.
I would guess 1 minus B encode error, uh, in, union transmission error, union decode error.
Okay, that's a rough guess. Let me write it in terms of events. That would be probability of a message with no error. That's required. That's the first thing you need to recognize what is required.
Yes.
So once you have identified that this is the required thing, the next thing is to check how do we proceed with the probability of no error. This can be found directly or can be found indirectly. I'm going to tell you both ways. I can find it directly or I can find it indirectly. Muhammad Faris.
Yes, Doctor. Directly 1 minus the addition of all that transmission, right?
I would say that is indirectly using the complement.
Okay.
How would you find it directly? No error means no encode error, no transmission error, no decode error.
Maybe complement all the errors, like For example, 1 minus b of the probability of encode error, and then 1 minus the complement of probability of transmission error, and so on, and then calculate all of them, like add them.
Exactly like Saud said, probability of no encode error and no transmission error and no decode error.
Doctor, intersection or union?
Now this is directly. When I'm saying directly, I'll talk about the union later, but now I'm saying no error, and no error means none of these errors. So that's intersection. I don't want an encode error, and I don't want a transmission error, and I don't want a decode error. Now look at the red highlighted thing. Now this is where the red highlighted thing will come into the picture. It says that the errors are independent, so this intersection will be changed to product only because of that red statement. If that red statement was not there, you cannot change this to the product. So this will simply be probability of no encode error multiplied by probability of no transmission error multiplied by the probability of no decode error. So the probability of no encode error, you have the probability of encode error. No encode error will be 1 minus 0.009. No transmission error will be 1 minus 0.01. No decode error will be 1 minus 0.001. This will give you the answer. That's the direct way of doing this question. But there is an easier, or I would say indirect method of doing this question. Like Faris was saying, you take the union and then you take the complement of that union. That means from the start, from the first step, when you say probability of no error, you convert it to complement 1 minus probability of at least one error. Either the encode error or transmission error or decode error, at least one of the errors. And then you say this is 1 minus probability of encode error union transmission union decode error. At least means union. And is it really a easier way? I don't think this is the easier way. This is even lengthy. How do you find the union now? Yes, anyone? How do you find the union now? Do you add? Is probability of A union B equals to probability of A plus probability of B? Or there is something minus also?
Minus the intersection.
Minus the intersection. So this is even longer solution. You can solve it. Yes, I'm not saying you cannot solve it, but this is even longer solution. You will solve it like this. 1 minus probability of encode plus probability of transmission plus probability of decode minus the intersection of encode and transmission minus the intersection of encode and decode minus the intersection of transmission and decode plus the intersection of all three of them. That's how you open the union of three events. Probability of A union B union C, that is equal to probability of A plus probability of B plus probability of C minus the two-way intersections plus the three-way intersection. And this will be what? This will be 1. As I said, this is the longer way. This is the tough way. 1 minus probability of encode error is 0.009. Transmission error is 0.01. Decode error is 0.001. E intersection T will be 0.009 times 0.01. E intersection D will be 0.009 times 0.001. T intersection D will be 0.01 times 0.001 plus the intersection of all three, that will be 009 times 0.01 times 0.001. And this will give you exactly the same answer that you got with the blue color. But again, that solution with the blue color is much easier and much quicker. Any question from these two solutions, Muhammad Faris?
Yes, doctor. Why I cannot do like add 0.009 plus 0.01 plus 0.001 and subtraction by 1?
Probability of A union B is not equal to A plus B. It's A plus B minus the intersection. So if you want to apply the addition theorem, you have to apply it completely.
Oh, okay. And 0.09, it is conditional, probability of conditional or normal probability?
No, there is no condition here. There is no conditional in this question.
Okay, thank you.
That's simply the probability of an encode error. Any other questions? Okay, now I'm going to start the next chapter, which is about discrete random variable. And before I start discrete random variable, I'm going to tell you what is a random variable. We talked about random experiment. Can anyone remind us what is a random experiment? Nawaf.
It is an experiment with more than one outcome.
With more than one outcomes, and you cannot predict the outcomes. So any procedure that gives you outcomes, and in this course you will be mostly interested in outcomes with numbers. So a process or an experiment that gives you more than one outcomes, and those outcomes are unpredictable. That's the random experiment. So let me give you an example of a random experiment. The same example that we have been doing. The example is that you have a box of 5 objects, and 3 of them are working, and 2 of them are defective. And from these 5, you pick 3 with replacement. That is the experiment, and you check whether these 3 objects are working or defective one by one. So this is your experiment. Now again, I'm doing this for the explanation, but you don't need to make the space manually. I'm going to make the space manually now. So when I pick 3, I think this is too much. Let me pick 2. 3 will be 125, and 125 is too much. I cannot make it. So let's make it 2. When you pick 2, I'll make the space manually, and I'll just copy it from the previous chapter. We have that space somewhere. Yes, we have it here. So I'll copy this one. And I'll simply paste it here. This is my space. That is random experiment. You go through a procedure, and the procedure is that I have a box of 5 electrical items. 3 of them are working, 2 of them are defective. I'll pick 2, and I'll check the status of those 2 objects, whether they're working or defective. That's my random experiment. Now from the random experiment, if I define a function, by the way, how many outcomes are there in this random experiment? There are 25 outcomes. So there are 25 possible outcomes. I highlighted them, some of them with the blue color, and some of them with the black, and some of them with the green color. So all in all, there are 25 possible outcomes of this random experiment. So if I tell you that look at the first outcome, let me zoom it in. Look at the first outcome. There is W1, W1. In this first outcome, how many defective items are there?
None.
None, 0. Look at the second outcome. How many defective items are there?
10.
0, 0. In the fourth one, there is 1 defective item. In the fifth one, there is again 1. In the sixth one, there is again 0. In the sixth one, seventh one, there is again 0. Again 0, 1, 1, 0, 0, 0, 1, 1, 1, 1, 1, 2, 2, 1, 1, 1, 2, and 2. So what I did is I converted every outcome into a number, and that number was either 0 or 1 or 2. And how did I convert every outcome into a number? I converted it with the help of a function, and that function was what? That function was number of defective items. If I define that function as x, number of defective objects out of 2 picked with replacement. So I'm using this function supplementary to the random experiment to convert every outcome into a number. So such functions are called random variables. These functions are called random variables. So such a function that assigns a numerical value to every possible outcome of a random experiment, such a function is called a random variable. Again, like the outcomes of a random experiment are unpredictable, the value of random variable is also unpredictable. When you perform the experiment, like I tell you, I have this box of 5 items. I pick 2 out of them. So before picking or before observing the 2 items, can you tell me what will be the number of defective items? You cannot. It will be either 0 or 1 or 2, but you cannot tell me whether it will be 0 or 1 or 2. So the outcomes of this random experiment, they are also unpredictable, like the random experiment. The value of this random variable is always unpredictable. Like the outcomes of random experiment, the values of random variable are also unpredictable. That is the property of a random experiment. Now, when you talk about the random variable, there are 2 types of random variables. In this course, we'll talk about these 2 types of random variables. There is one type that is discrete random variable. And there is the second type that is called continuous random variable. So your chapter 3 is about discrete random variables. Your chapter 4 is about continuous random variables. So we'll talk in detail about the discrete random variables in chapter 3. But before that, we have to differentiate between these 2 types. What is the difference? Can anyone guess what is the difference between discrete and continuous? Any rough guesses? Nawaf.
Continuous maybe in the, like when we had 2 defective.
Like we have 2 defectives. Take the example of this random variable x, which is number of defectives. Is this number of defective items, is this a discrete random variable or a continuous random variable? The one you defined here, x you defined as number of defectives. Forget about what are the values of x, that's more detail. But Omar.
Yes, discrete like integers.
Okay.
And continuous like rational number
Like
that have.
This basically concept is exactly borrowed from mathematics. Even in mathematics, you define continuous domain. When you define continuous domain, that means you can have any value in the interval.
Yes.
So I'm going to write the general definition here because there are some exceptions where the categorization is confusing. So this general definition will make it less confusing. A discrete random variable is a random variable that can get only specific values. For example, the one I defined, X, number of defectives. What are the values this variable can take? This variable can take either 0 or 1 or 2, the 3 specific values. And a continuous random variable is a variable that can take any value in a given interval. For example, I define Y as height of participants. Now, height of participants can go up to as many decimal points as you want. It depends upon the scale at which you are measuring. If it is a good scale, you can go like up to 3, 4, 5 decimals, as many decimals as you want. So the height of participants, the values will be, the variable can take any value in a given interval. But here the values are coming in jumps. In discrete random variable, the values are coming in jumps. You can have either 0 or 1. There is nothing between 0 and 1. There are gaps between the values, between the possible values, I would say. Now, this does not mean that the integer values are always discrete and non-integer are always continuous. No. There are some special examples where even the non-integers are discrete, where the values are coming in jumps. So you remember the general definition, the one I wrote on screen, that's the general definition. Yes, the common definition is that the integers are discrete, but sometimes even the non-integers are discrete. I'll give you some special examples. When you go to the shoe market and you try to buy the shoes, there is one special type of shoe size which is like a 5, then there is 5.5, then there is 6, then there is 6.5. I don't know whether it is American or British sizes. There are one which says 40, 41, 42, 43, but there is one more which says like 7 and then 7.5 and then 6.5 and 6 and 5.5 like this. They go like this. Where X belongs to 5 and then 5.5 and then 6 and then 6.5 and then 7. And I don't know what is the maximum. I think they go all the way up to 9. Although this is decimal, but this is still discrete. Why it is discrete? Because this is getting specific values and there is nothing in between the values. There is 5, then there is 5.5, and that there is nothing between 5 and 5.5. So the general rule is whenever there is a variable that can take specific values, whether it's up to no decimal point, whether it's up to 1 decimal point or 2 decimal points or whatever, if it is taking specific values and there is nothing between the values, that's discrete. And if the domain is continuous, that's continuous. Any question from the differentiation between discrete and continuous? And most common example of discrete will be number of somethings. Mostly you will be using number of somethings as discrete. The integers will be discrete, but there are some special examples you may encounter in real life and exam, which seem like continuous, but they are discrete. I'll give you one such example. Any question before that? If you have any questions, you may go ahead. OK, now in the remaining 25 minutes of the class, I'll quickly talk about the discrete random variables. Once you define the discrete random variable, what is the next step? We study the discrete random variable. And how do we study the discrete random variable? Number one, we try to identify all the possible values of discrete random variable. Like for your example, the possible values were 0, 1, and 2. We find the corresponding probabilities against each value. So let us try to do these two things in terms of a table. For our example, you had a box of 5 items. 3 were working, 2 were defective. You picked 2 with replacement. And you said X is number of defectives out of these 2. So what are the possible values of X? You said there is 0, there is 1, there is 2. These are the 3 possible values of X. What are their corresponding probabilities? What is the probability that X will be 0? I'll copy the space again. For your convenience, I'll copy the space again. What is the probability that the number of defectives will be 0? Now this is a pure probability question. Anyone who can answer, raise your hand. This is like a question of probability, which says probability of an event, and you have to apply the basic definition, n of A divided by n of S. Nawaf.
9 over 25.
9 over 25. Why, Nawaf?
Because you have 9 zeros.
Because we have 9 outcomes that belong to your event. Your event is that X is 0. That's your event. So you're trying to find the probability that X is 0. Let me write it in terms of what we were doing in chapter 2. We're trying to find probability of X equals 0. That is n of X equals 0 over n of S.
Correct.
So we have 9 outcomes from event X equals 0, and we have 25 total events. Muhammad Ali.
Yes.
Do you have a question?
No.
Ammar. Amjad Ammar.
Yes.
Any question?
No answer.
Jafar Muhammad.
No questions, answers.
Okay, Ammar, can you tell me what is the probability of x equals 1?
12 over 25.
12 over 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, Ammar, can you tell me what is the probability of x equals 2?
4 out of 25.
4 out of 25. So when you do those two things, you come up with the table. And this table is what? This table contains all the possible values of x along with their corresponding probabilities. Such a table that gives you the possible values of a discrete random variable and their corresponding probabilities. Such a table is called probability mass function. It's called probability distribution or probability mass function. Muhannad.
Doctor, I don't understand why we use the random variable. It seems harder than the usual thing, dealing with numbers instead of the actual probabilities.
Yeah, I'll explain that. Just hold on for 10 minutes, and if you don't get the answer, get back to me. Hold on for 10 minutes, and by the end of the class, if you don't get the answer, you get back to me. Why we go towards the random variable, why we don't solve the question as it is, using the concepts of chapter 2. Okay, so in this question, we defined random variable x, which was number of defectives. We identified all the values of x, which were 0, 1, 2. We found the corresponding probabilities, which were 9 over 25, 12 over 25, and 4 over 25, respectively. And we said that this table that gives you the possible values of discrete random variable and their corresponding probabilities, this table is called probability distribution or a probability mass function. And there are two properties of this table. Those two properties are that the probabilities are always non-negative and the sum of probabilities is always 1. If you take the sum of this column, that will always be 1. So these two properties are always fulfilled by this table. Now I gave two names to this table. I gave it a name probability distribution. And the logic behind this one is how the total probability, which is 1, is distributed among three possible values of x. It is distributed like 9 over 25 belongs to 0, 12 over 25 belongs to 1, and 4 over 25 belongs to 2. So the total probability is always 1. You are trying to see how this total probability is distributed among the different values of x. That's the logic of calling it a probability distribution. Why am I calling it a probability mass function? Because I can write this table in terms of a function also. Although in exam we will not expect from you that you have to write this in terms of function, but I can if I want to. For example, in this question, I can write it as probability of x equals x is 2 combination x multiplied by two over 5 to the power x multiplied by 3 over 5 to the power 2 minus x, where x is 0, 1, or 2. Now, if you put x equals 0 in this function, tell me what do you get? You get what? X equals 0 is 2 combination 0 multiplied by 2 over 5 to the power 0 multiplied by 3 over 5 to the power 2 minus 0. So you get what?
9 over 5.
You should get 9 over 25. If you put x equals 1 in this function, that will be 2 combination 1, 2 over 5 to the power 1, 3 over 5 to the power 2 minus 1. You should get 12 over 25. I did not calculate but I know it will be 12 over 25. And similarly, x equals 2, that will be 2 combination 2, 2 over 5 to the power 2, 3 over 5 to the power 2 minus 2. That will be 6 over 25. Is it? 4 over 25. Now don't ask me how I got this function. I'm only trying to say why I called it a probability mass function, because this table can also be written as a function. We don't expect you to write it as a function, but this can be written as a function. That is why we also call it a probability mass function. And if you look carefully in this function, the one I'm going to highlight, this function, you'll be able to see that the probabilities are basically simply the functions of x values. This function, that is 2 combination x multiplied by 2 over 5 to the power x multiplied by 3 over 5 to the power 2 minus x. The only thing that is unknown in this function is what? It's x. So you plug in the values of x, you get the probabilities. That means the probabilities are functions of x. These probabilities are functions of x. Any question until this point that is confusing you? I'm going to move forward now towards the question. A question I had: why do we go towards random variable? Why we don't simply solve it with the help of probability? Like here, if I ask you a question, find the probability that there is no defective item in your pickings. So you can find this probability directly from the probability question. No defective means you count the outcomes where you have no defective. These are 9 outcomes, and you divide it by 25. Why do you have to come towards probability? This random variable definition. The answer to this one is the use of random variable is not just the probabilities. The basic use of random variable is coming. That's what I'm going to discuss now. Once you have established a random variable, you have made its probability distribution, which is nothing but the simple concepts of chapter 2. There is nothing new in this one. Once you have done that, now you come towards the uses of this random variable. What are the uses of this random variable? This probability distribution of a random variable can be used to find many properties of this random variable. The probability distribution of a random variable can be used to find many properties of that random variable. For example, what properties? For example, the mean of that random variable, the variance of that random variable, the standard deviation of that random variable, the median of that random variable, and so on, many properties. For example, I ask you a question that I have a box of 5 items, 5 electrical items, and I pick 2 of them. The organization of the box is like there are 3 working and 2 defective items. I pick 2 of them with replacement. On average, how many defective items do I expect in my picking? Look at the question now. One concept I'm trying to deliver from the question is that these three words, they have the same meaning. The average, the mean, or the expected. All of them refer to the mean. Then I'm talking about my variable, number of defective objects, which I defined earlier. If you pick 2 with replacement, number of defectives, it has this probability distribution, which I wrote in terms of table. It was 9/25. What was the 14? 14/25. 12/25. This was the probability distribution we had. Now, from the basic probability concept, you cannot answer this question. What is the average number of defective objects if you pick 2? What is the mean number of expected number of defective objects you will get in your hand when you pick 2? How many defective objects do you expect? It can be 0, it can be 1, it can be 2. What is the mean? We don't know. To find these properties, you need the probability distribution of the random variable. I'm going to quickly write down the formulas for finding all these properties. The mean of a random variable can be found using this formula. The expected value of x, which can also be denoted as mean of x, which can, I think these are the 2 notations. This is equal to summation of x multiplied by the probabilities. So you need this new column, x multiplied by the probabilities of x, and the sum of that column is called the mean of x, or the expected value of x, or the average value of x. Similarly, if you're interested in the variance of x, have you covered this variance concept in the lab? This will be expected value of x square minus expected value of x whole square, where this expected value of x is simply what you found in mu of x, and where expected value of x square is summation of x square times p of x equals x, and expected value of x, you found it already. There is a formula here, this one. So let us try to find the mean here. For mean, we need a new column. That is, we multiply these two, x multiplied by p of x equals x. So that will give me 0 multiplied by 9/25, that is 0. 1 multiplied by 12/25, that is 12/25, and 2 multiplied by 4, that is 8/25. So my mean is the sum of this column, and the sum of this column is 20/25. Which is it 0.8?
Yes.
Okay, so this is 0.8. So when you perform this experiment, on average, you expect 0.8 defective items in your 2 pickings. I can also say if you do this experiment a very long number of times, infinite number of times, every time you will get a value of x. The average of those values of x will be 0.8. In the next class, I will ask you this question, that you have talked about this mean, median, standard deviation, variance in the lab. And you're talking about this mean and variance here also. What is the difference between this mean and that mean? What is the difference between this variance and that variance? Be prepared for this question. I will ask you this question in the next class. For now, I'm going to find the variance of x. The variance of x has a formula. And if you look at this formula, I need expected value of x square in this formula, which I'm going to find it by creating a new column here, x squared times p of x equals x. So 0 square is 0 multiplied by 9 over 25 will be 0. 1 square is 1 multiplied by 12 over 25 is 12 over 25. 2 square is 4. 4 multiplied by 4 is 16 over 25. And the sum of this one is 28 over 25. So the variance of x here, which is denoted by sigma square of x, that is equal to 28 over 25 minus 0.8 square. Can anyone tell me what is the final answer?
Zero
0.48.
0.48. Go up to 4 decimal points. Minus 0.8 whole square. 4800. There are no third and fourth decimal, so we cannot go. Okay, so this is the variance. Similarly, I can find the standard deviation of x.
Dr. Why we need a 4 decimal?
For exam, from exam point of view, whenever there is rounding needed, I'm doing this for your practice to make it a habit. Whenever you need rounding, round up to 4 decimal points, because in the exam will always be rounded up to 4 decimal points.
Okay, thank you.
So the standard deviation is 0.48, the positive square root of this 0.48. This is where I will need 4 decimals. So the standard deviation will be 0.6928. We found 3 properties of this this random variable, which was number of defectives. We found its mean, we found its variance, we found its standard deviation, and I hope you have covered these concepts in lab also. I want you to compare these concepts with the lab concepts. What is the difference between this mean and that mean? Both of them, you're calling them mean. But what is the difference? They are not same concepts. There you use the formula of mean as x bar equals summation x over n. You did not use this formula. This formula is different from summation x over n. So what is the difference? And why is the difference? Why both of them are called means? Similarly, there was a formula of variance there. You're using a different formula here. What is the difference? This is the question for you to think. I will summarize the class now. In the class, we talked about what is a random variable. A random variable is a function that assigns numeric values to the random experiment. There are 2 types of random variables. There is discrete, there is continuous. In this chapter, we are covering discrete random variable. What are the things we do after defining the discrete random variable? We try to explain the discrete random variable in terms of its probability distribution. What is a probability distribution? Probability distribution is a table or a function that tells you all the possible values of random variable along with their corresponding probabilities. I repeat, this can be written as a table or a function. Then, what are the 2 properties of probability distribution? The 2 properties are that the functional values are always non-negative, because these functional values are nothing but the probabilities, and probabilities cannot be negative. And secondly, the sum of all probabilities is always 1 for the discrete or continuous, whatever random variable. Then we discussed, after defining the probability distribution, what are the uses of this probability distribution of a random variable? The uses are, we can find different properties of a random variable using this probability distribution. What properties? The average value of the random variable, the amount of variation in the random variable, which is studied by the variance, the standard deviation of the random variable, the median of the random variable, the percentile of the random variable, and many more properties we can study. So we studied the two formulas for finding the mean of the random variable and for finding the variance or standard deviation of the random variable. And we implemented those two formulas and we got the answer. Now, if you have a question from today's class, you can raise your hand. And if you don't have a question, you can leave at this point.
So the answer of this question is 0.8.
The answer is 0.8.
Yes, okay. Thank you.
Omar Adnan.
Yes, Doctor. I would ask about is there a formula sheet in midterm and the quizzes?
Yes, of course, there will be a formula sheet where all these formulas will be given.
Can you share it before the quiz?
I will share it. If I don't share it by today evening, give me a reminder, either through a Teams message or through an email.
Okay, thank you.
But I will share the formula sheet of whole course. So that will be chapter by chapter. For you, that will apply about only chapter 2 and 3, but I'll share the whole course.
Okay, no problem.
Okay, Muhannad.
Thank you.
Doctor, I have a question about the homework. Is it okay to write just only the answer?
It's perfectly fine to not copy the questions, not just the answers. You have to do the stepwise solution, but you don't need to copy the questions.
Yes, that's what I mean.
Yeah, not the final answer. You need to do the solution, but it's perfectly fine not to write the question, not to copy the question again.
Oh, okay.
I would recommend it, not just perfectly fine, but I would say don't waste your time in copying the questions. Abdulaziz.
Yes, Doctor. When do you have office hours?
Now, maybe in 3 or 4 minutes, I have created another team where all of you are registered. So I will start a session there now in 2 or 3 minutes.
And is it only Tuesday or?
It is scheduled on Tuesday and Wednesday, and if you want another day, let me know one day in advance, we can schedule.
Okay, thank you.
It says Tuesday, Wednesday, or by appointment.
Okay.
Or even without appointment, if you have something to say, if you see me available.